Hello students, myself Prakash Lavande, Sri Tilok Jain, Higher Secondary Vidyalaya Pathardi. Students, in today's lecture, we will discuss about the very important topic from chemical kinetics, and that is the rate law. Now, what is this rate law? Before that, you know that the rate of chemical reaction depends upon different factors, and among them, the two important factors that mainly we are going to consider in this particular chapter. The first one is the concentration of reactants and the second one is the temperature. Now, as you know that the rate of chemical reaction at a given temperature, that means here we have considered the first factor on whose the rate of reaction depends, that is the temperature, and this rate of reaction it depends upon what parameter? Another factor, that is the concentration of reactants. Are you getting me? So these are very two important factors that actually determine the rate of chemical reaction. So what are the two parameters? The first one is the temperature and second one is the concentration. Now these two parameters that actually determine the rate of chemical reaction, and for almost all kinds of reaction except few exceptions, the rate of chemical reaction that depends upon concentrations of reactant, but remember at a given temperature. Why I am saying at a given temperature? Because the rate gets affected because of temperature. That means rate depends upon concentration and temperature. Okay, and this relationship between the rate of chemical reaction and concentrations of reactant, so this is called as rate law. Is it simple? Okay, so this relationship between the concentration and rate, that means rate as it depends upon concentration, that means rate and concentration relationship is nothing but rate law. Are you getting this? So that you know, theoretically we have studied about this. Rate depends upon concentrations of reactant. But here, as far as this particular kinetics topic is concerned, we are not dealing with all reactant concentrations. That means whenever we express rate law in that reaction, or I can say for any chemical reaction, it is not the case that all the concentrations of reactants determine the rate of reaction. That means during the course of reaction, let us say 3 reactants are involved. That means all these 3 reactants actually do not determine the rate of chemical reaction. Are you getting me? That means in the chemical reaction, only out of 3, either 1 or either 2, that may only determine the rate of chemical reaction. That means whenever you write the rate law expression, in the rate law expression, on the left hand side you have the rate of chemical reaction, okay, and on the right hand side you have the concentrations of reactants. But remember, here only those concentration terms are only permitted to write on right side on whose concentration rate of reaction depends, and that's why the rate law is also called as a true rate law. Are you getting this? True rate law. That means in the rate law expression, whatever concentration terms are involved, that actually determine the rate of chemical reaction. And once you know about this in basic things, then you can easily apply for any chemical reaction. Okay, so whenever we talk about the rate law, so as you know that left hand side you have rate and on the right hand side you have the concentrations. Okay, now already we have studied about this rate in previous my videos. Okay, so what is rate? Rate is nothing but the change in concentrations of reactant or product per unit time. That means production of product, or either there is a loss of reactant over the time. Now for any chemical reaction, let's say your chemical reaction like simple reaction H2 plus I2, and that gives you twice HI. So for this particular chemical reaction, as far as rate is concerned, so left hand side your rate. Okay, so this rate you can write, you have already expressed in terms of average or instantaneous rate. So this rate is nothing but, you can write rate as a minus delta H2 upon delta T, or either you write minus delta I2 upon delta T. Okay, so this is nothing but the left hand side of the equation. That is the rate of chemical reaction. Now on the right hand side, you have the concentrations of reactant. So what are these concentrations of reactant? On whose concentration only rate of reaction depends. So that are that expression. So this rate expression, whenever you have to apply rate law for any chemical reaction like H2 plus I2, that gives you twice HI. So first of all, what are the important condition? The first condition is your reaction should be balanced. Whenever you apply the rate law. Okay, now that expression gives you information about the loss of reactant or production of products relate to each other. So how these are related to each other, that mainly expressed in the rate law. That means rate law is not a theoretical concept. What I am saying, rate law is not a theoretical concept. Only if you know the balanced chemical equation, you can't apply the rate law. So to apply the rate law, you have to study that particular chemical reaction experimentally. You have to study it according to the kinetic point of view. And whenever you study the reaction according to the kinetic point of view, then you can realize actually what are the reactants on whose concentration the rate of reaction depends. That means rate law is a experimentally determined quantity or experimentally determined fact. That is nothing but the rate law. Okay, means you just do the experiment, and then after you will get what are that reactant on whose concentration rate depends, and then after we will write the rate law. That means it describes how the rate depends upon the concentrations of reactant. Okay, so for any chemical reaction, generally we can apply the rate law. Okay, so for that purpose I will consider a general chemical reaction. Okay, I will consider any general chemical reaction and I try to apply the rate law. So consider a general chemical reaction. Okay, so suppose your reaction is like this, AA plus BB, and that gives you the product. Now this is a general chemical reaction to which we have to apply now the rate law. Now here what this equation tells you, here small a and small b are the number of moles of reactants A and reactants B. Okay, and that gives you the product. Now if you apply the rate law, so by applying a rate law to this equation, so applying rate law, so you apply the rate law to this equation. So what do you get? You apply the rate law, so you will get information rate that is directly proportional to. So what? According to the rate law we have studied, rate is nothing but relationship between the rate and concentrations of reactant. That means A is the first concentration term and B is the second concentration terms. Okay, and here the stoichiometric coefficients are A and B, but here I am not writing A and B, I will write as a X and Y. Why I am writing as a X and Y? Because X and Y, they are determined experimentally. Okay, suppose simple, if X is 0, that means A is to 0, that means the rate does not depend upon concentration of A. Okay, that means this X and Y, where this X and Y are determined experimentally. So they are determined experimentally. Okay, and here the another factor, that is if you x and y, they are determined experimentally. Okay, now if you write this rate expression further, then rate is equal to, if you remove this proportionality sign, what do you get? Rate is equal to a raised to x and b raised to y, and this is very important equation. Okay, so left hand side your rate, that means you write any concentration terms or any product terms also, and any concentration terms as a rate, and on the right hand side you have k into product of two concentration terms, okay, raised to suitable power. But here remember, we are not writing as it is a and b, but we are writing x and y, because these x and y, they are determined experimentally. Okay, now we will study in detail about this k. Okay, that is the proportionality constant. Okay, so rate is equal to k into concentration of A raised to x and concentration of B raised to y. Okay, now this k is called proportionality constant. This k is called proportionality constant, or it is also called as rate constant. Okay, and this rate constant is very important factor in chemical kinetics, because this rate constant measure the rate of reaction. This rate constant measure the rate of reaction. Okay, now to define this rate constant, okay, to define this rate constant, we assume that, let us say, to define this rate constant, we put let us say concentration of reactant is equal to concentration of product is equal to 1. Okay, is equal to 1 raised to x and raised to y, so is equal to 1. So what do you get? So rate is equal to k, means we have put the unit concentration, concentrations of reactants A and B, and your powers also 1 and 1. So in that case we will get rate is equal to k. So from this we can define what is rate law, what is this rate constant. Okay, so what is this rate constant? So rate constant, which is very important constant, that is going to measure the rate of reaction. So this rate constant we have to define now. Remember, each rate constant, higher the value of this rate constant, faster will be the rate of reaction. Okay, that means this rate constant is very important parameter for any chemical reaction or in the rate law also. So this rate constant, it becomes rate of reaction under what condition? At unit concentrations of reactants. So this rate constant is the rate of reaction, when concentrations of reactants are unity, that means 1. Okay, that means if the concentration of reactant is 1, and at that time the rate constant becomes the rate of reaction. Okay, so this is the definition of your rate constant. Okay, this is the definition of your rate constant. Now this few important points about this rate constant as a write as a characteristics of this rate constant K. So what are the characteristics of this rate constant K? So important two characteristic, it is independent on concentration, it is independent on concentration of reactants, it is independent on concentrations of reactant. And what is second thing? It depends upon temperature. It is independent on concentration, but it depends upon temperature. So K get influence because of temperature only. If temperature changes, K changes, but as concentration of reactant changes, K doesn't change, and that's why this rate constant has much more significance in the rate law. Okay, reaction depends upon concentrations of reactant. Now here we will apply the rate law for particular specific chemical reaction. Let us say a chemical reaction like this between H2 and I2, the reaction between H2 and I2. So this is that first reaction. Okay, H2 I2, that gives twice HI. Now for this particular reaction, if you want to apply the rate law, so what do you do here? Right, left hand side your rate, and on right hand side you have the concentrations of reactant. So here concentration of reactant H2 and I2 both are involved here. This expression is the true rate law. This expression gives you information that rate of reaction depends upon concentration of H2 as well as concentration of I2. That means rate depends upon both the concentrations of reactants. Okay, now here another example where you have N2 plus NO2 plus CO, NO plus CO2. Now if you your reactants are NO2 and CO. Now in this particular reaction, if you apply the rate law, so rate law means relationship between the rate and concentrations of reactant. So here out of these two, only one reactant term is involved, that is NO2. NO2 is taken here and not CO. That means rate does not depend upon concentration of CO, but here rate depends upon 2 moles of NO2. That means rate depends upon 2 moles of NO2, and rate is independent on concentration of carbon monoxide. The third example between H2O2 decomposition, that gives twice H2O plus water. Now if you apply the rate law to this equation, this is found to be like this, rate is equal to like this. That means although there are two reactants are involved, but actually rate depends upon concentration of the 1 mole of H2O2. So this is how rate law differ from the your actual theoretical concept. Okay, so we have applied rate law for different chemical reactions. So in short, finally I can say what is rate law. So rate law is nothing but it's a experimentally determined equation. So how does this rate law is obtained? From experimental study. Okay, so experimentally determined equation which relates rate of reaction and the concentrations of reactants on whose concentration rate of reaction depends. So this is called as rate law. I am going to repeat once again. What is rate law? It's a experimentally determined equation which relates the rate of reaction and concentrations of reactants on whose concentration rate of reaction depends. That means here rate does not depend upon concentration of CO, and that's why we have not mentioned in the rate law expression. We have only written rate is equal to K into NO2 raised to power 2. means here CO term is not involved, means rate is independent on concentrations of reactant. So this is what about the rate law. In the next video we will study about the order of chemical reaction. Till then, thank you.